Now, if we let t be any real number, so we're going to let that be that angle right now in this diagram, and let p of some x and y be the terminal point of this unit circle, then what we have is we're going to define the following 6 trigonometry functions. Okay. And that is that sine of t is really just the y value. So this is sine of t. Cosine of t is your x value. And tangent of t is your y over your x. And we're assuming that x is not equal to 0 because otherwise we'd be dividing by 0. And then cosecant of t, abbreviated CSC, is our inverse, 1 over y. Secant of t is 1 over x. And cotangent of t is x over y. They're inverses. Now, there are some special angles that we often use in trig. And those are 0, 30 degrees, 45 degrees, 60, and then 90. And if you recall, we can write them in radians as 0, pi over 6, pi over 4, pi over 3, and pi over 2. So to calculate what sine is, we'll refer to this right here. Sine is just the y values. So if we're looking at 0 degrees, essentially we're just looking at straight across. And so what we have is the point P of x, y, and this is a unit circle, so it has a radius of 1. It's just P of the point 1, 0. So x is 1, y is 0. Go ahead and substituting, y is 1 for sine, cosine, or sorry, y is 0 for cosine, x is 1 for tangent. We have y is 0 over 1, and so sine, cosine, tangent, cosecant, secant, and cotangent. Right, so y was 0, x was 1, tangent is 0, and then going through cosecant, 1 over y, but y was 0, so we can't do that, so this is going to be undefined. In fact, probably should back up a little bit and write over here that also we have y cannot be 0, and over here we have y cannot be 0, and then over here we have x cannot be 0, just so that we make sure that we're not dividing by 0. Secant is 1 over x, and x was 1, so secant is just 1 over 1, or 1. And then cotangent is x over y, from right over here, x over y, and we get that is also undefined because we cannot divide by 0, y is 0. At 30 degrees, when we have that, we can refer to this right here. So we're going to have a 30, 60, 90 triangle, and we can use this nice triangle right here For 60 degrees, we would use this triangle, which is really an equilateral triangle, 60, 60, 60, and then you just kind of cut that in half, and now you have another 30, 60, 90. And then for 45, we have an isosceles triangle, where we have this length and this length are equal, because if this is 45 and that's 90, this is also 45, so we have an isosceles triangle. So filling out for 30, sine is just our y, so our y is 1/2, our x is that, so sine is y, sine is 1/2. Cosine is x, x is square root of 3 over 2, and then continuing on, tangent is y over x, so tangent is 1/2 divided by root 3 over 2, and if we do some simplification, then we're going to get this is root 3 over 3. Cosecant, CSC, is 1 over y, so 1 over 1/2 would give us 2. Secant is 1 over root 3 over 2, which gives us 2 root 3 over 3. And then cotangent would be root 3 over 2 divided by 1/2, which is just root 3. I'm going to go ahead and just fill out the rest, but you can see where these all come from. We're looking at our 45-degree triangle, our 60-degree triangle, and just filling out what is y and what is x. If it's sine, it's just y, cosine x, tangent is y over x, cosecant 1 over y, 1 over x, and x over y. All right, so this is what the table looks like filled out. Now, this may seem intimidating to see a big table like this, but actually notice that we can rewrite certain things. So if we looked at our angle t, then we look at sine and cosine, and so t goes from 0, pi over 6, pi over 4, pi over 3, pi over 2, or if you want to do it in degrees, it doesn't really matter. What we have is for sine, so we look up here, and as sine, as we go down this column, right now it might not look easy, but if we just take square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2. Well, square root of 0 over 2, square root of 0 is just 0. That's what we had here. Square root of 1 is 1, and then over 2, and these are the same, but square root of 4 is 2. 2 over 2 is 1. And then cosine works the opposite way. So we have square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, and then square root of 0 over 2. So that's how we can find sine and cosine.